There is a stove built from a steel barrel, a stack of fire bricks, and a bucket of clay that will heat a 1,500 square foot house for 18 hours on a single log. It costs about $12 in materials if you scavenge. 40 if you don't. It burns 90% less wood than the cast iron stove your grandfather used. It produces almost no visible smoke. It is so clean that in parts of Washington and Oregon, where wood burning is restricted by law, this design is one of the only wood heaters legal to install. Mother Earth News documented households heating 1,500 to 3,000 square feet on 1 or 2 cords of wood per year, 1 cord for an entire winter. The Wisner Engineering Manual, the definitive technical reference on this system, puts combustion efficiency above 90% in normal use. A modern EPA wood stove is rated 60 to 70. You have never heard of it. That is not an accident. Here is where it gets interesting. The answer starts about 400 years ago in the cold pine forests of Norway, Sweden, and northern Russia. A period called the Little Ice Age had locked Europe into a stretch of brutal winters from 1550 to 1850. Temperatures dropped, growing seasons shortened, and in the north, people were running out of trees. They had a problem your modern heating engineer would recognize instantly. An open hearth, the kind you see in every medieval painting, throws roughly 5% of its heat into the room and 95% up the chimney. They were freezing inside their own houses while burning the forest down around them. So they invented something different. They built massive stoves out of soapstone, fire brick, and clay. Not stoves you stood next to, stoves you built the house around. The Norwegian kakelovn, the Swedish kakelon, the Finnish tulikivi, the Russian pechka. Same engineering principle in every one. In 1763, Frederick the Great of Prussia was so alarmed by deforestation that he held a competition for the most efficient wood stove ever designed. A craftsman named R. P. Baumer won it in 1764. His design used what he called heat accumulating mass. The idea was simple. You did not keep a fire going all day. You burned a single, very hot, very fast fire, 1 to 2 hours, then you let it go out. And the stove, weighing 1 to 4 tons of stone, slowly released that stored heat into the room for the next 12, 16, 18 hours, meaning they figured out that you do not need to burn wood continuously to stay warm. You need to capture the heat from one short burn and let it leak out slowly. That is the entire trick. To your eye, a regular wood stove is a fire in a metal box. To a thermodynamics engineer, it is a heat leak with a flame inside. Cast iron heats up fast and cools down faster. The moment you stop feeding the fire, the metal goes cold, the room goes cold, and you are awake at 3 in the morning loading another log. Now look at fire brick. To your eye, it is just a brick. To a physicist, it is a battery for heat. According to the Brick Industry Association technical notes, fire brick holds 80% more thermal energy than cast iron of equal weight. Its thermal conductivity is 1/45th that of steel, meaning brick absorbs heat like a sponge and lets it out 1 drop at a time. Smoke and creosote, the gunk that clogs your chimney and causes house fires, ignite around 1,300 degrees Fahrenheit. A regular wood stove tops out around 1,000. So the smoke escapes unburned, up your chimney, into the air. That is fuel you paid for, leaving your house. The Scandinavian design and its modern descendant burn at 980 degrees Celsius. That is over 1,800 Fahrenheit, hot enough that the smoke itself becomes fuel. There is almost nothing left to come out the other end except carbon dioxide and water vapor. The mechanism is physical. Hot fire plus dense mass equals stored heat. No electronics, no thermostat, no moving parts to break. The physics do not negotiate. Now think about what you are paying for right now. The average American household spends just under $1,200 a year on heating. Roughly $2,500 a year if you live in the Northeast and you heat with oil. Over a 30-year mortgage, that is between $36,000 and $75,000. Burned, just to keep the inside of your house above 55 degrees. A $12 stove built from a barrel and some clay does that job on 1 or 2 cords of firewood a season. 1 cord runs around $200 delivered, or 0 if you have trees on your property. So why is every house in America built with a forced air furnace, a propane line, or an electric baseboard? Why does the residential heating equipment industry generate over $30 billion a year in the United States alone? Why has the masonry stove, a design proven across an entire continent for 400 years, never made it into a single mainstream American home builder catalog? You already know the answer. It is not because the design does not work. It is because a stove that lasts 80 years, uses almost no fuel, and requires no service contract is a terrible business model. The furnace industry depends on annual fuel deliveries, 10-year replacement cycles, and recurring service calls. A masonry mass heater offers none of those things. That is not a coincidence. Now here is the part that brings it into your reach. In the 1980s, an engineer named Ianto Evans was studying traditional cob building in Oregon when he asked a question nobody had asked. What would happen if you took the Scandinavian masonry stove and stripped it down to nothing? No soapstone, no imported tile, no mason's apprenticeship, just dirt, clay, sand, straw, and a single steel drum. What he built is called the rocket mass heater. It runs on the same principle as the Norwegian kakkelovn, short, hot burn. Thermal mass absorbs the heat, slow, radiant release. The only difference is the materials cost about $12 instead of $12,000. This is the build. You need a 55-gallon steel drum. You can pull one out of a recycling yard for free or buy a used food-grade barrel for $10 to $30 on Craigslist or Facebook Marketplace. Do not use one that previously contained chemicals. 20 to 30 standard fire bricks. Home Depot or Lowe's carries them for about $2 each. You need fire brick, not regular brick. Regular brick cracks at high heat. 1 8-foot section of 6-inch single-wall stovepipe. Home Depot, around $30. Most cabins under 1,500 square feet use the 6-inch system. Larger homes step up to 8-inch, a sack of clay. If you are lucky, you dig it out of your own yard. If not, a 50-pound bag of fire clay runs about $15 at any masonry supply store. A pile of sand, roughly 3 wheelbarrows worth, free from a creek bed, or about $5 per bag from the hardware store. 1 bale of straw, Tractor Supply, around $8. Perlite or wood ash for insulation around the heat riser. About $10 for a bag of perlite. Total cost if you scavenge the barrel and dig your own clay. $12. Total cost if you buy everything new and pay retail, around $80. Step 1. Build the foundation. You need a level, fireproof base directly on a structural floor. Concrete pad, brick patio, or compacted earth with a layer of fire brick on top. The completed system will weigh between 1,000 and 2,000 pounds. Your floor needs to carry that. If you are building inside a wood-framed house, check the joists first. If they are not rated for the load, run a doubled 2x10 support underneath. Step 2. Build the J-tube. This is the heart of the system. Stack your fire bricks into the shape of a capital J. Short vertical feed tube on one end where you drop the wood. Horizontal burn tunnel along the bottom. Tall vertical heat riser on the other end. The riser height should be 2 to 3 times the height of the feed tube. That is what creates the draft. That is what makes the system sound like a small rocket when it is running. The hot air punches up the riser so fast it pulls the flame sideways through the burn tunnel. You will hear it. The first time you light it, the sound is unmistakable. A soft, steady roar. That is how you know the geometry is correct. Step 3. Insulate the heat riser. Wrap it in a perlite and clay mix or pack wood ash around it inside a metal sleeve. The riser has to stay hot. If it loses heat to the surrounding air, the burn slows down and you get smoke. Insulation keeps the temperature inside the riser above the 1,300 degree threshold where smoke itself ignites. Step 4. Cap it with the barrel. Take your 55-gallon drum, cut the top off, and invert it over the heat riser. Leave about a 2-inch gap between the top of the riser and the inside of the barrel top. That gap is where the hot gases hit the steel, turn 90 degrees, and start flowing back down the outside of the riser. The barrel becomes a radiant heat source. You can boil water on top of it. You can cook on it. You can grab it through a thick towel and feel the warmth before the room ever heats up. Step 5. Build the manifold and the ducting. At the bottom of the barrel, the cooled exhaust flows out through the horizontal stovepipe. That pipe is what you bury in the thermal mass. Snake it through a long bench, a low wall, or a built-in bed. The longer the run, within reason, the more heat the mass extracts. Keep horizontal runs under 30 to 40 feet, or the draft starts to fail. Step 6. Pack the mass. Mix 3 parts sand to 1 part clay. Add chopped straw for fiber, just enough water to make it stick. This is cob, the oldest engineered building material on Earth. People have been mixing this exact recipe for 10,000 years. Pack it around the ducting in a thick, rounded form, 6 to 10 inches deep. Smooth the surface. Let it cure slowly over a week with small test fires. Fire it too hot too fast and it cracks. When you are done, you have a long, low bench you can sit on, sleep on, eat dinner next to. And in the middle of January, when the fire has been out for 12 hours, that bench will still be warm to the touch. Now here's the mistake that ruins 90% of builds. The heat riser is too short. People look at the J-tube, see a foot of vertical pipe, and think that is enough. It is not. If the riser is only as tall as the feed tube, you do not get enough draft. The fire smolders. Smoke backs up out of the feed. The whole thing fails. And the builder concludes that rocket mass heaters do not work. The riser needs to be 2 to 3 times the height of the feed tube. Minimum. If your feed tube is 16 inches, your riser is at least 32 and ideally 48. That is what creates the chimney effect inside the barrel. That is what produces the rocket sound. That is what burns the smoke before it can leave the chamber. Get that one ratio right, and the system works the first time. Get it wrong, and you will spend a winter convinced the design is broken. And here's the part that surprises most people. The same stove does more than heat. The barrel top reaches 400 degrees Fahrenheit during a burn. You can sear a steak on it, boil a kettle in 8 minutes, bake bread on the side closer to the riser. The bench stays warm 16 hours after the fire goes out. Drape wet clothes over it overnight. They are dry by sunrise. Run the ducting under a planting bed and the same heater warms a greenhouse. Tropical plants in Montana in February. Some builders have run copper coil through the cob mass and fed a domestic hot water tank. Free hot water. No electricity, no gas line, no utility bill, 1 stove, 1 log, 4 functions. And here is the proof. A homesteader outside Missoula, Montana, who has been heating exclusively with a rocket mass heater since 2013, documented his fuel use on homestead living. 1 cord of wood per winter. Climate zone 5, house around 1,200 square feet. His neighbors with conventional wood stoves burn 4 to 6 cords. Same climate, same square footage. The Wisner engineering team reports thermal storage of 6 to 12 hours of radiant heat from a single 1 to 2 hour burn. With a larger mass and a fully loaded feed tube, well-documented builds have pushed retention to 16, 18, even 24 hours in well-insulated cabins. That is the 18-hour log. It is not magic, it is mass. Wikipedia documents anecdotal fuel reductions of 80 to 90% compared to conventional wood stoves. Even at the conservative end, you are cutting your firewood load in half. Do the math on that. $600 to $1,000 a year not spent on fuel. Over 20 years, that is between $12,000 and $20,000. Burned by you, not for you. Now the honest part, because this channel always gives you the full picture. A rocket mass heater is excellent for a single connected space, a cabin, a great room, an open floor plan with high ceilings. It is not a drop-in replacement for a forced air furnace in a 4-bedroom suburban tract house with closed-off rooms and a finished basement. The mass heats radiantly. Walls and doors block radiant heat. If you have a sprawling, compartmentalized layout, you need either multiple smaller systems or a different approach entirely. Safety. You need a chimney that exits the roof safely, just like any wood stove. You need a carbon monoxide detector. You need to keep combustibles 18 inches away from any exposed metal surface during a burn. The same precautions you would take with any wood-fired appliance. These systems have been built and used safely in the United States for over 40 years, and in Europe for 400. They are not exotic. They are simply forgotten. Here is the part that stays with me. 400 years ago, a farmer in northern Norway with no electricity, no engineering degree, no internet, figured out that you could heat a wooden house through a winter that drops to 30 below by burning 1 fire a day in a stack of stones. He passed it to his son. His son passed it to his grandson. For 20 generations, the knowledge moved forward through families, through villages, through trade routes, until somewhere in the middle of the 20th century, in the rush to wire every house to a utility grid, the knowledge stopped moving. It did not disappear. It was just no longer profitable to teach. Now you have it back. You know that a single log in the right stove can heat a house for 18 hours. You know that the design is older than the United States. You know that the materials cost less than a tank of gas. You also know what a $30 billion industry depends on you not knowing. Share this with someone who is heating with propane right now and watching the bill climb every December. They deserve to know there is another way. Their grandparents probably knew. Somebody just stopped passing it down. Knowledge like this does not disappear on its own. It gets buried. This channel digs it back up. Thanks for watching. I'll see you in the next one.